Yeah, today I'm interested to just focus on insertion sort. Well, of course, I have a certain file opened here, whatever. But what I'm truly interested in is the logic behind the code. Whatever the code is available, we will go through it regardless. The idea is well, let me just use this array as a simple data set. We're interested to arrange it in ascending order. The intention behind insertion sort is to start with a certain element, let's say at the position 1 of this particular array, and slowly sort it backwards. Meaning you're going to increment by one index value and you will slowly move backwards and just sort it out instead of working out with the entire array. Let's say we work out with bubble or some other sorting method where you just go through every single damn element of the array. Instead, we are going to focus towards incrementing by one index value and slowly working backwards and sorting just the left hand side of the array until you end up with the final element or final index. Well, the idea is we're going to start with 8 and we verify is 8 less than 9, which is at the position 0. So, what we're going to do is just put up 9 at the position of 8, gather up the position of 9, then tap down 8. So it's not a process where you're just replacing things. You're trying to insert at that position. So you create a duplicate, find the index value of the duplicate, then put in your target value. Well, why don't we pick up a larger index? Let's say 5. 5 is of course less than 6, which is your target. So we point out 6 at the position of 5. When we move back to 7, 7 is greater than our target, which was 5. So the position which is next to it, we'll input 7. And we move backwards towards 9. The same process happens, it's greater than 5. So duplicate creates. Then you move on. Again, another duplicate. At this position, you have nothing backwards to go. So you stop here. We find out the value at this position, which is your index value is 0. So right over here at this index, we'll input the value which was our target. In this manner, you're going to slowly sort backwards. I've just given you a mini example with one of the several elements. Of course, you can have thousands of elements, even in dice positions. What we have done over here is just declared an array, an integer array, one dimensional with 10 elements with a descending order, and I am interested in, let's say, an ascending order, similar to what I've tried. So I'll just show you the results, then we may talk about what's happening as well. So as you can notice, it has printed out in an ascending order. I've just used the same in dice, increasing, nothing backwards, nothing crazy. We have declared something known as the size of the number of elements or the size of the array being num size. Target for, of course, our target element being smaller than the previous one, your I and j being whatever, let's say variables or identifiers to work with for loops. Right over here, I begin with I equal to 1 being this position, so you have something to compare towards your left. You can't start, as such. We set our target as a of I, meaning your 8 is being referenced. Your j is equal to I minus 1, meaning we're talking about index position of 0. At the beginning of the entire operation, of course. Right over here at the why do we need the while loop is solely because at number 5 we have flown backwards until the end, until the very last position being 0 or index position 0. being accessible. So we need a while. Well, we need j to be greater than equal to 0, meaning even if you start at, let's say, position where I'm referencing 4, you can go backwards as much as you want, but only until the index position 0. So you choose j to be that particular variable or identifier to play that part. Well, I mean, you may practically even use I, but that will hinder the process of for loop or create confusions. The other condition that must be true is, of course, the target at position 1 must be less than at position 0. At position 0 you have 9, at position 1 you have 8. So it is true. So based off j plus 1, meaning position at position 1 you're just transferring the value of position 0. Well, j minus minus, it'll reach to a point where j greater than equal to 0 only for the first set of operations. So you just input add index available, add index 1, or at the index that is specific to our requirement, the target value, which satisfies what we require. And the entire process just happens quite a couple of times until the end of the array, of course. Then what we've done here is just print it out. We've used the same I element and printed the array. However, it is using just a simple format specifier and a new line to back this up. This should be the backbone, as in the entire idea is what I'm truly interested in. That gets me excited, which is how I practically like you guys to follow up as well. You guys could connect with us using the email or groups that are provided in description. I'm totally interested in following it up and maybe discussing things that you guys will be interested to talk about, whether it's C language or something else. Let me know where you'll see me grow or change or implement certain new things. I just try to sort it out. Yeah.